Well, welcome back to Rocking Math and a lesson on pre-algebra. Today we will talk about sequences. We are looking at Math Standard 8.5a, where we will predict, find, and justify solutions to application problems using appropriate tables, graphs, and algebraic expressions. Well, we will also find and evaluate algebraic expression to determine any terms in an arithmetic sequence with a constant rate of change. Well, what do we mean by sequences? A sequence is an ordered list of numbers. It's an ordered list of numbers. Not an ordered list, but an ordered list of numbers. Each number in the list is called a term. And an arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. What in the world are we talking about? Well, let's see, can we first come up with maybe how we find or create these particular sequences. Let's say, for instance, that down below I have some triangles. Well, actually what I did was I created these triangles with my little, I call my little toothpick. So I have 3 toothpicks in the first triangle. I just laid them across each other. Now, what I want to do is see if I use 3 for the first one and I want to create another one. Now remember, here's my first one, that's my second one, and my third. Now here, if I wanted to create another triangle, all I need is 2 more toothpicks. Okay, that makes sense, right? That one stays there, so you just connecting that one there and that one there. Now, if I wanted to create 3 triangles, all I need is 2 more toothpicks. So, how many toothpicks do I have in all for the 3 triangles? I have 1, 2, 3, 4, 5, 6, 7 toothpicks. And that created me 3 triangles. Well, if I continue this same pattern, you look closely, if I continue this same pattern for 4, 5, and 6 triangles, how many toothpicks would I have? Remember, I started with 3, so let's make sure we understand that. I started with 3, then I added 2, that's 3 plus 2, that gave me 5, and then 5 plus 2 gave me 7. So what would happen if I wanted to create 4? Again, I would use 2 plus 2, that would give me 9. And then if I wanted to create 6 triangles, then that would give me 9 plus 2, which would give me 11, and then 11 plus 2, which would give me 13, and so forth. So what that is telling me if I wanted to create 4 triangles, or I would need 9 toothpicks and so forth. But now, how many additional toothpicks are needed for 4 triangles? And how many toothpicks will you need for 7? For each additional toothpick, we need, for each additional triangle, we need 2 toothpicks. And again, if we wanted to see how much we would need for 7 triangles, then of course all we need to do is add 2 to 6, because this is 6, remember? So we would add 2 to 13, and that would give us 15 triangles. Well, what I want you to understand, just by looking at this, that the number of toothpicks needed for each pattern form a sequence. Okay, and then we just talked about that actually that sequence is a list of numbers, and see how we actually created the numbers. Now, writing this down differently so you could see it, and I'm going to change colors here briefly. Writing this down where you could see it, we could see that actually 3 and 5 and 7 and 9 and 11 are all doing something in common. So what are they doing in common? If we take the first term, and let's go ahead and really classify these when we talk about these particular terms or whatever. So this first number is a term, and it's term 1. 5 is a term, and it's term 2. The next number, the third number in the list, is term 3. This is term 4, and this is term 5. Each number in the list has its own specific identity. Okay, so don't get confused here. Remember, the first number is term 1, the second number term 2, and so forth. So if I ask you what is term 4 in this list, your answer will be 9. What is term 5? And it will be 9. So now let's come up with what these terms and how what's this difference that I told you, or this common, what we have in common. If we will take term 2, I'm going to change ink one more time. If we will take term 2 and subtract it by term 1, we will get 2. And if we take term 3 and subtract it by term 2, oh, faster than what I was thinking, again, we would have 7 minus 5, which is also 2. We take term 4 and subtract it by term 3, we would have 9 minus 7, which is 2. And if we take term 5 and subtract from it term 4, and we will have 11 minus 9, which is also 2. So what this is telling us, since we have 2 for each one of these particular terms, we have a common difference, and we're calling it a difference because we are subtracting the first number, or the first term, from the second term, the second term from the third term, the third term from the fourth, and the fourth from the fifth, and so on. So this is called a common difference, and you have to understand it wouldn't be a common sum because we would have to be adding, but because we are subtracting, the difference we get, and as long as that difference is the same, it is called a common difference. Okay, so make sure you understand that. So we subtract, we get our common difference, and we can use our common difference to create additional terms, like term 6. The common difference here, even though we got a common difference of 2, so that says we can add 2 to 11 and get 13. And if we wanted to find term 7, we would add our common difference, which is 2 to 13, and get 15, and so on. Okay, I know maybe it was a little information, but it's always good, I think, we get in and work some problems and you understand. So again, just take your time, look at what we just covered, and then we will definitely deal with identifying next arithmetic sequence.